ATAP. Project TANGO is a journey that we've embarked upon over the past 18 months with universities, research labs, and industrial partners to build upon the last decade of research in computer vision and robotics, concentrating that technology into a very unique mobile device.
When you're outdoors, you can use your cell phone and you can use GPS and find where you are and where you want to go. When you enter, the moment that you enter a building, GPS is not available anymore. So we need to create other ways for being able to find where we are.
Project TANGO is producing a solution to the visual navigation problem for how devices can stay localized in 3D space.
I did the research initially that developed the 3D vision algorithms that the rovers use to drive safely on Mars, and I worked on that as a grad student in the 80s, and then I came to JPL, and then it turned out that TANGO is similar in that you've got this device in your hand, you need to know where it is. One of the best ways to do that is to use the camera in the device to track features in the room.
The problems we encounter in that research are the same problems we're struggling with now in our autonomous driving project and in the Project TANGO, which is how to re-recognize places that you've been before, even though the environment has changed.
Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple hours something that would take us months or even years before because we didn't have this technology readily available.
What happens if you have all of these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that at the moment.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe in the vision.
Localization and mapping is there on your phone and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
You know, being able to map your home. Oh, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. And we are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.